Alright, so this problem says a 2 microfarad capacitor and a 4 microfarad capacitor are connected in series across a 1000-volt potential. The charged capacitors are then disconnected from the source and connected to each other with terminals of like signs together. Find the charge on each capacitor and the voltage across each capacitor. Alright, so let's do a diagram first. Okay, so here's 1000 volts, and what you're doing is here are these guys in series. Okay. 2 microfarads and 4 microfarads. Okay, now here's the deal. When capacitors are connected in series, the charges are the same, and the charge is the same as the charge on an equivalent capacitance. Okay. So what we'll do is we'll find the equivalent capacitance, find the charge on the equivalent capacitance when you connect a 1000-volt battery, and that is the charge that's on each one of them. Okay, so let's find the equivalent capacitance. And these are all in microfarads, so this is 203/4 and C equivalent okay. Now notice that whenever you have a series combination, the equivalent capacitance should be smaller than any of those capacitors, and the equivalent capacitance is 1.33, which is smaller than 2. Okay, so that's a cross check always for you guys. Okay. All right, now let's find the charge on that equivalent capacitance. A 1000 volts. And so this is equal to 1.33 millicoulomb. Okay. So the charge on each of those capacitors is 1.33 millicoulombs. Okay. Now what are we doing? So the charge, and then disconnected from the source and connected to each other with terminals of like sign together. Find the charge on each capacitor and voltage across each capacitor. Okay, now here's what we're going to do. So now you have disconnected them, okay, and then connected like that. Okay. So this was the 2 microfarad capacitor. Here's the 4 microfarad capacitor. Okay. By the way, so let me do it. This is the before 2 microfarads. Each had a charge of Q was equal to 1.33 millicoulomb. Okay. So now you took this and connected them. When you connect them, what happens? Charge will redistribute. It'll redistribute such that what is it that will be same when you have two capacitors that are connected in parallel? The voltage across the capacitors must be the same. Okay, that's how the charges redistribute. So Here was Q initially. Okay, so C equal to Q over V. So V, that tells you V is Q over C. Okay, so now let's say the charges are Q1 and Q2 after you connected them. So Q1, and this we'll call this C1, C2. So Q1 divided by C1 should equal Q2 divided by C2. Okay. It seems like, so now we have to find Q1 and Q2. We have two unknowns, so we need a second equation. And the second equation is coming from here. Q1 plus Q2, the charge on these two guys, should equal to the charge on these two guys. So should equal 2Q. There is the second equation. Okay. So now we should be able to solve for Q1 and Q2. Okay. So this tells us, so we'll call this 1, this 2. 1 tells us that Q1, 1 tells us Q1 is C1 by C2 Q2. C1 is 2 microfarads. By 4 microfarads and Q2. So Q1 is 1/2 of Q2. Okay, and we'll substitute that over there. So in 2. So Q1 is 1/2 of Q2 plus Q2 equal to 2Q. 3/2. Q2 is 2Q. Q2 is 4/3 Q. And so Q1 will be 2/3 Q. Okay. And so Q2 is 4/3 of 1.33 millicoulombs. And Q1 should be half of that, so that's 0.8789. Okay. All right, so here's what's happening in this problem. When you have two capacitors connected in series, the charges are the same on the capacitors. Okay, and what is the charge on each of these capacitors? So if the two capacitors are equivalent to this single capacitor, whatever the charge is on this one is what is the charge on these guys. Okay, and then when you disconnect these capacitors and connect them in parallel, what happens is the charges redistribute such that the voltage across them is the same. Okay, and that's so that's the principle we've used. Okay, so that completes that problem.